Good day everyone. This is a tutorial about the first order ordinary differential equation about the chemical engineering course. Because at some time in every engineer's life comes an exasperating sensation of frustration in problem solving. Somehow the answers or calculations do not come out as expected. Oftentimes, this outcome arises because of errors in the handling of equations that involve too much unknown. But an orderly method of analyzing problems of presenting their solutions represents training in logical thinking and is considerably greater value than mere knowledge of how to solve a particular type of problem. So, we have an example here. Under certain conditions, it is observed that the rate at which a solid substance dissolves varies directly as the product of the amount of undissolved solid present in the solvent and difference between saturation concentration, which is expressed as amount of solute per amount of solvent, and the instantaneous concentration of substance, which is expressed as amount of solute per amount of solvent. If 30 kilograms of solute is dumped into a tank containing 150 kilograms of solvent, and at the end of 12 minutes, the concentration is observed to be 1 part solute in 30 parts of solvent, find the amount of solution after 20 minutes if the saturation concentration is 1 part of solute in 3 parts of solvent. We must first find the known and unknown components. Through inspection and analyzation from the problem, we got these data. Let X be the amount of solute dissolved in the solution at any time t. dx over dt is the rate at which a solid substance dissolves, and 20 minus x is the amount of undissolved solid present. 1 over 3 is the saturation concentration. X over 120 is the instantaneous concentration of the substance, and 120 is the volume of the solvent and is fixed. It is said that the rate at which a solid substance dissolves is directly proportional to the product of the amount of undissolved solid of the difference between the saturation concentration and the instantaneous concentration. This expression would then be dx over dt is equals to x times 20 minus x times 1/3 minus x over 120, where k is the proportionality constant. By the inspection, this OED can be solved separately and can be put into the form g of y dy is equals to f of x dx, and by algebraic manipulations, possibly combined with transformations such as y over x and solved by integrating both sides. For the integral, we apply partial fractions. We see that the factors in the denominator are all linear and none is repeated, that where no two of the factors are identical. Solving a and b as constants. Then, then, multiplying we get For us to determine a and b, we need to guess x so that a and b can both at time 0.
So x at a is equals
When x is equal to 0, a is 6. When x is equals to 120 over 3, b is negative 1 over 20. We have now the integral. Let u is equals to 2t minus x and du is equals to negative dx. Let v equals to 1 over 3 minus x over 120 and dv is equals to negative dx over 120. By integration, we get negative 6 in 20 minus x plus 6 in ln times 1/3 minus x over 120 plus c and negative 6 ln times 20 minus x plus 6 in times 1/3 minus x over 120 is equals to kt plus c. 6 can be put into the form 6 in 1 ln 1 over 3 minus x over 120 over 20 minus x is equals to kt plus c. After this, we manipulate ln to be 40 minus x over 20 minus x times 120 is equals to ac times kt over 6 is equals to ae dt. When t is equals to 0, x is equals to 0, no dissolved solute initially. Then, a is equals to 1 over 60, 40 minus x over 20 minus x times 120 is equals to e dt over 60. When t is equals to 12, x is equals to 1 over 30 times 120 is equals to 4. Then you will get x is equals to 1 over 30 times 120 equals to 4. Then you will get 40 minus 4 divided by 20 minus 4 times 120 is equals to e b times 1 2 e is equals to b times 12 over 60. Then b is equals to 0.0098. Thus, 40 minus x over 20 minus x times 120 is equals to e to the power of 0.0098t over 60. Simplifying gives 40 minus x over 40 minus 2x is equals to e to the power of 0.0098t. Thus, x is equals to 40 minus 40e to the power of 0.0098t over 1 minus 2e to the power of 0.0098t, where x is the amount of salt dissolved at any time t. When t is equals to 20 minutes, x is equals to 4t minus 40e to the power of 0.0098 times 20 over 1 minus 2e to the power of 0.0098 times 20. The answer is x is equals to 6.051 kilograms of solute. This is the amount of salt dissolved after 20 minutes. You can, of course, formulate your own strategy for solving problems. Everyone has a different viewpoint, but the adoption of the well-tested general strategy presented may find helpful to you. Thank you.